And we're back. Let's continue on with our exploration of finding confidence intervals for population variance. Okay? So I put the equation back up on the top here, this scary looking thing. But again, I just want to reiterate, it's not as bad as it looks. All we need to do is find these three variables here. So we need to know n, meaning how many things we're dealing with in our whatever our problem is. S squared, that's just the square of the standard deviation, and then we have to find our chi-square lower and upper values. These are probably the most confusing things to calculate, but they're not that bad once you have a table and you kind of practice with it a little bit. So let's just break this down. Okay, so now, the problem that we have here is that we are told this, right? We have 10 randomly selected automotive batteries, and that is, of course, going to correspond with our n here, right? We also know what our confidence interval is. It's supposed to be 95%, so that's going to tell us these things. But, and here's the kicker, we are not told directly what our S squared, or standard deviation squared, value is. Instead, we are given just this list of number of automotive batteries. Okay, so now, this is something where the calculator is critical, because if you have to do this by hand, this takes forever. Okay? But let me just walk you through the process. Given these sets of values, here is how you would calculate standard deviation. Standard deviation is equal to, all right, and it's going to look frightening, but just bear with me. It's going to be the square root 1 over the number of things that we are calculating, which in this case it's 10, okay, times this. I'm drawing this horribly. Okay, this weird symbol in mathematics just simply means the sum of whatever is inside the parentheses. So we just add up whatever this is. Okay, so it's going to be xi minus x bar squared. Okay, I know this looks terrifying. And again, I'm just showing this to you just to show you this is how it would work, but nobody would expect you to work this out by hand. But let me just explain what this means. Well, let me just explain what this means. Okay, so basically, x bar is supposed to be that means the average, right? So basically, we would just find, whatever the average is of all these numbers here. So that would just mean adding them all up, right, and then dividing them by 10, whatever that would be. And I think I calculated this in advance. What did I find? Hold on a second. I got, actually, I do have it somewhere, but nevertheless, we'll come back to that in a second. Okay, so that would just be the average, right? So that's the average of all the data that we're talking about. The xi thing just means taking each one, so 1.73. So, for example, like say we worked this out and we found that the average was 2. And it's not, but just pretend, just bear with me for a minute. Okay, so if that was the average, then xi would just mean, okay, take each one of the data points and subtract 2 from that. So that would be 1.73 minus 2, 1.81 minus 2, 1.57, all that. Okay, you can see how tedious this would be to do this all by hand. But so we would just take every single data point, subtract the average, and square that. So, like, for example, that would just be something like, again, pretending that our average is 2. It would be something like 1.73 minus 2, and then square that. And then we would keep going. We would do then 1.81 minus 2, and square that. And all of them. And then you'd add all of that up and divide it by, in this case, 10, right? Because n is 10. And then whenever you did all that, take the square root, and boom, there is your standard deviation. That's a lot of work to do by hand. Calculators will do this for you. Depending on which calculator you have, it's going to be a different method, so I would strongly recommend Googling whatever the brand name of your calculator is. Say it's a TI-84, or TI-85, or a TI Inspire, whatever it is. Just Google that plus calculate standard deviation. And there'll be something there where you can just plug your numbers in, click enter, and it'll spit out what your standard deviation is. I did this with Excel because I have a computer. All right, and this is what I got. So here, I entered in all my data right there, and then this is what ended up, oops, let me switch the mouse. Hold on a second, I'm working this up. Okay, so then I have some sort of function where it says calculate standard deviation of a sample, and I just entered in A1 through A10. For you Excel gurus out there, just skip all this. But anyway, that would be how you would calculate the standard deviation for a list of data. All right? And then, again, very importantly, back to this, we want standard deviation squared, right, for our formula. So I took that number. Let me come back to Excel. Where is it? Here it is. Took that number and I just squared it, right? So C1 squared, meaning this, whatever's in here, square it, got me 0.048. Okay? So that tells me that, whoops, that was weird. That tells me that the numbers that we need are, we know that n is equal to 10. We know that the standard deviation squared is equal to, what was it again, 0.04 something? I forgot. I'm going to round it off to 0.048. 0.048, and then the last thing that we needed to know was the chi-square values. Okay, so let's just set this up, what we have so far. I know this is running long again, but here, let me scroll down and give us a little more space. Here we go. Okay, so remember, our formula is, it's going to be n minus 1, so that would be 9, times the standard deviation squared, which is 0.048. I know my handwriting is just atrocious. And then we need our chi-square for the lower limit. And, okay, I'm just repeating all this on the top, over our chi-square for the upper limit. Okay, so L for lower, U for upper. Okay, so then let's just look at what did they tell us that we wanted? 95% confidence interval. Okay, so again, remember, that means we have a maximum of 5% error to play around with. So what we would do is we would divide that error rate into two parts here, right? So 5% divided by 2, that gives us 2.5% to play with on either end of that chi-square distribution, right? So that means, so remember this end is 0% and this end is 100%. So that means that we go up 2.5% here, down 2.5% there. So that means our lower limit, this one, I'm going to switch colors, I just feel like it. Our lower limit is going to be 0 up 2.5%, so that's going to be 0.025, right? And then the upper limit is going to be 100% go down 2.5%, so that's going to be, what is this? I can do this, 0.975. So those are our chi-square values. So let's pull up our list. What do we got? Okay, so given that our degrees of freedom are 1 minus the amount that we started with, so if we're dealing with 10 things that we are testing. Oh, excuse me. So if it's 10 things that we're testing, that means our degrees of freedom are 9. So we're in this column somewhere here. And then the two values that we had were, upper limit was 0.975, so that's this, 2.7. And the lower one was this one, 19.02. Okay? So then let's just plug those in. Let's go back to, here we go. So our equation over here, we have 9 times that. Let me erase a little. Well, okay. The eraser's going to take too long. 1 second. Let's do this. Okay, so just ignore that for a second. The upper limit was 2.7. So all that divided by 2.7. And the lower limit was 19.02. Okay, and then there you go. You just crunch the numbers there and figure out what you end up with. And it should be, pause this and check me, see if I'm wrong, but it should be something like, we should end up with 0.023 on the bottom, the lower limit, and then it's going to be 0.16 for the upper limit. And there you go. That is going to be our confidence interval for the population variance. And then when it says to take the to find the sample standard deviation for the population, the interval for that. Remember, standard deviation is just the square root of the variance, so just take the square root of all this stuff, and there you go. And that gives us standard deviation is going to be somewhere in between the square root of that, which, again, check me on the calculator, but should be 1.52, and then the other one should be 0.4. And there you have it. This one was a little bit more complicated because we weren't told directly what the standard deviation was. We had to calculate it, but with a decent calculator, it shouldn't be too difficult of a process.